Hi, welcome back to the Watercolour Westport Stories podcast. Today we are pulling back the curtain a little bit and interjecting an episode with a very special guest who is here to give us some insight from his very long and respected career in building science. We have had the privilege of having Gord walking alongside us as we have begun the journey of building a resilient, beautiful, energy efficient, comfortable housing community. And he's going to share with you insights to how he got here. And we just want to build community, get to know each other better. And Stephen, I would love you to share how you got to meet Gord and how he brought him into the journey and into the fold of Landark Homes. So we welcome today Gord Cooke.
Thanks very much, Wafa. A pleasure to be here again. I had a pleasant drive up, and it's been half a dozen visits at least, and always a pleasure to come.
Yeah, I know I have learned so much from you, and today I think we'd like to take a little bit of a different course in our conversation and get to know you more than get to know about the knowledge that you have to share. But Stephen, maybe you can start by letting us know how you got to meet Gord.
Well, every energy advisor we would ever speak with would always mention how much they had learned from Gord and from his company Building Knowledge. And my brother-in-law happens to know him as he was a heating contractor, and he said, yeah, Gord's a great guy. And so I reached out to Gord, and we attended spring camp, so we learned a great deal at Gord's spring camps that he's put on. Both Kevin and I have attended, and we've benefited enormously, because the phrase that I think of when I think of you, Gord, is a long obedience in the same direction. Is for more than 20 years you've been trying to drill into our hard-headed builders who resist change, how important it is to build healthy environments. And for this whole idea of health and wellness, we're just so honored to have you here. So thanks for making time, Gord.
Thank you. That's very gracious. It's I learn as much when I have these opportunities. I learn as much as anyone. So it's that collective, right, that we're all working together. It's interesting in a complex industry. You mentioned an industry that struggles with change for, frankly, lots of legitimate reasons. It's not just hard-headed. It's just the realities of the complexity of the business. That means, to some extent, you have to be careful about change.
So you're a scientist, a consultant, an educator. Pull that together. How did that journey start for you?
Yeah, it's a good point. I wouldn't say I didn't start off as a scientist. My formal training is in engineering.
Okay.
Had a job at General Motors back in 1980. And those who remember that far back knew that the car industry specifically, but in general, the economy wasn't great. General Motors said to us, we've hired you all, young engineers, we'd like you to stay, but we're not going to have much for you to do for the next couple of years. So to some extent, they encouraged us to leave. And I ended up moving out west and meeting through a government organization, this amazing manufacturer, small little manufacturer of something called a heat recovery ventilation device. And this was an outgrowth of research that was being done in the 70s, specifically in Ottawa, Saskatoon, and Edmonton, on high-performance energy-efficient housing that came out of the 1970s oil embargoes, where Canada was struck with this dependence on foreign oil. So a whole industry started on researching how do we reduce our dependence on foreign oil, specifically in housing, because we were an oil-dominated heating fuel at that time. And one small piece of that was the ventilation side. That is, how do we ensure these high-performance houses maintain a very high level of air quality? So a small manufacturer of this device hired me. His name was Rick Olmsted. He was a visionary guy, and I'm going to say everything I learned in terms of how to conduct myself, how to help the industry, all came from Rick. He was an amazing mentor, a guy who knew how to get things done. You can imagine a small manufacturer building a piece of mechanical equipment on the prairies, and I'd phone up suppliers and they'd say, Saska, where? How do I get materials out to that location? And perhaps of interest at that time, there was 4 manufacturers at that time of these this little industry. Why? Because it was research that was being done at the University of Saskatchewan, and 4 different people went out and said, I could make those. 3 of those disappeared. Rick was one of the few that stayed, was able to endure. He built that industry. And you can imagine I'm trying to build and promote something called the heat recovery ventilator that nobody knew what it was or what it did.
Right.
And I had to educate on that. I moved back to Ontario. I was from Ontario. Moved back to Ontario, became their agent here, and recognized I would talk to builders and they would say, you should put this in your houses. And they'd say, why? I said, because you build tight houses. And they would say, do I? And I said, I don't know. So I went out and bought the equipment to understand how their house was being built. Then they would ask me, how do I do that? I said, I don't know. So I went and took training. Right. And that I became this term building scientist. Wasn't even a term. And I fed off, I would say, the research that was being done. And my role has ended up being kind of the communicator of that research. I don't necessarily do the research, but I became the communicator of that, I guess, is what I've always envisioned my role to be, and try to help understand how do we integrate not just that idea, but other new ideas to improve the performance of houses.
Yeah, that performance, it's interesting when you say leaky, because as soon as you say that word, people think water.
Yes.
They understand how to keep water out of a house and they want that. The leaky air part is a little bit trickier and more nuanced, and I think that the progress of the type of technologies and advancements in materials is also an interesting part of that. I'd love to hear a little bit more about the leaky air part.
Very interesting you say that, because homeowners kind of get it. I don't want air leaking in out of my house. But the building industry, it was a communication problem. Builders always had this notion that walls have to breathe, that houses need to breathe. And we've struggled communicating that correctly. What we've always wanted is we've wanted walls and attics to be airtight, but we've wanted houses to be ventilated. And we've always had ventilators. They're called windows. That's been a code requirement since the 40s to include windows. But we've struggled to get this understanding of unwanted air movement across a wall. I think most homeowners would say, well, how much dust, how many bugs, how much pollen do you want coming through an electrical outlet? Of course, we'd say none. And yet you'd say, well, if I seal that up, does that somehow create a cavity that's a problem? And we would say, no, the science would say we're fine. The tighter the walls and attics, the better. But we still need houses to be ventilated. And we ran into this issue where at the same time we were trying to make houses more efficient, we also ran into things like we started air conditioning houses, so windows are closed more often. We started to worry about noise and dust and security, so windows were closed more often. So we come from an era where mom would come in, I remember, old enough to remember, I'll open your window an inch, dear, open your brother's window an inch, and that'll create a nice draft. Now this is a smart woman, 5 teenage boys. When you have to open up that bedroom door and wake those kids up for breakfast, she's doing a good thing when she's ventilating. So
fresh air is better than all that stale air of those teenagers asleep.
So 1 girl, 5 boys, and she kind of knew. So she knew ventilation, but we kind of lost track of ventilation. And so now in houses, high performance houses, made it way in the code. We have more and bigger windows than ever before. This house being an example of that. But in the case where people don't feel like opening their windows for fresh air, we have now ventilation devices, mechanical ventilation. We'll call them fresh air machines that allow you to control the amount of air that comes in and out of your house. And that really ends up being very useful from a control of your environment, right? If we're going to be in this environment, we'd like it to be healthy. How do I control that? If I have unwanted air movement across our walls and heaven forbid wood fire smoke that we're now experiencing, we don't want that coming in, and we don't want the dust, the pollen, we don't want to pay the energy bills. So isn't it nice to know we have a device that gives us just the right amount of fresh air at the right time and is able to filter it, heat it, cool it before it comes into the house. So it's just one small piece of that high performance that I've been pleased to be part of.
I can imagine that that progression of the technology or the devices that have been used. Reflect on that for a minute, and just like if you were to say how far we have come, what do you think in terms of the homeowner experience has improved over the time that you first made an HRV versus the equipment that we use now?
Right. And so those early days, the equipment didn't work very well. It had lots of technical problems, like any new piece of equipment. And again, lots of research done at the University of Saskatchewan. I personally spent about 500 hours in this test lab. I always say it's at minus 25. Well, I wasn't in the minus 25 chamber. I was in the warm chamber. But it took a lot of research to figure out how to make that appliance work. And so now it's an appliance that's in a house that I would say is mature. It's like any other appliance, has fans and filters, lasts 15 to 25 years, but it gives you the ability to get fresh air. Along that same path, though, there was other technologies, improvements in windows, improvement in insulation systems, improvement in heating systems, all being done as part of this improvement of high performance. And the early days, it was indeed about energy efficiency. Remember, to reduce our dependence on foreign oil.
Right.
And if we did, rather than trying to make new energy, if we just conserved. In fact, the name of the company back then, Rick's vision, Rick Olmsted's vision, conservation energy systems. Conservation energy, just as important as nuclear energy or gas energy, it was conservation energy. For every piece of energy I conserve, that means one less that I have to bring into the house or pay for. So it was all based on energy efficiency. We now know, Stephen, it's more than that, right? It's now we have more to think about in terms of where does that fuel come from, carbon emissions, greenhouse gas emissions. So now, we went from an off oil program and then an off electric program. Now we're at natural gas. We've been blessed with this beautiful, clean natural gas, really cost effective, but now we understand it has impacts with respect to greenhouse gases. So now we need to go further and think about greenhouse gas reductions, which piggybacks off of energy efficiency, but goes a step further.
I think a lot of people feel climate anxiety, and they feel helpless to do anything about it. I would be interested to hear your comment, though, on how much of an impact can a homeowner have because we look at a house and we think, what's so different about this space? You walk into a Landark home in Westport and it's got drywall, it's got trim, it's got hardwood floors. What is that empowering aspect of this home that is different than any other?
It is interesting, isn't it? Us personally, yes, industry needs to do their bit and transportation needs to do it. But personally, there's kind of three big impacts. The energy or the greenhouse gases we emit to stay comfortable, heat and cool our houses, stay alive, heat and cool our houses. The greenhouse gas we emit when we drive a vehicle, and then what we eat, right? We all understand that meat-based products meat-based foods, if you will, have a big environmental impact. So you think about in a housing world, what does that mean? Well, we all want bigger houses, brighter houses, we want more windows, but at the same time we want to reduce consumption. And it should be encouraging for people to know, if you took that house from the 70s, that was built in the 70s, fast forward, new house today, brand new house today, because of code changes, because of that research, Canadian research, I got to say this, it's a 50-year story, journey, if you will, of Canadian building science research that's been exported around the world. German program, Passive House, was all based on Canadian science. Energy Star program in the US is all based on Canadian science. So we've exported it all. Here in-house, the new house today, for the same square footage, uses about 1/8 the amount of energy that a house built in 1970s. Still not good enough, but 1/8. This house that we're in here today uses 1/2 the amount of energy that a brand new code built house is. That is minimum building code, which is great, still uses twice as much energy as this house today. And you go, but I'm not seeing the differences, right? A little thicker walls, a little better windows, better air tightness, better basements, and all of that means 1/2 the amount of energy, which directly cuts your greenhouse gas emissions effectively in half. That's before you think about adding solar panels. These houses, Stephen, I think our last assessment was roughly 60% reduction in greenhouse gases in this house compared to, let's say, a code-built house.
And even at the CHBA meetings 2 years ago in the fall, when they pointed out that if it's built in Ontario, because the Ontario energy grid is so clean, instead of roughly 3,800 kilograms of CO2, this is around 300 kilograms of CO2. So it's almost like a 12-fold reduction, just because It's not a obsolete home. And I love saying that because I started when I was 16 in construction in the summers, and now I'm 60. So 44 years ago versus, building to the 10-year ahead 2035 building code. Relatively speaking, I tell people not much has changed. And that's kind of, I think, pathetic and sad. And yet, this idea of a third, reducing our carbon footprint 12-fold with the home. And also by living in a walkable community, only about 1% of communities are built intentionally to be walkable, not car-dependent communities. And so, skip the solar panels, just go net zero in a walkable community. And that too can up to 1/10 reduce your carbon footprint for transportation. So it's just remarkable. We can't really help people too much with the food they eat,
Right.
but we sure can help them with a walkable community.
It's very empowering.
And that's a nice way of saying it. It's one simple, it may not seem simple, but one simple non-compromising choice. Why wouldn't you do this when it's available to you? And people say, is it going to look ugly? No, come have a look. These are beautiful houses. People worry there's not going to be any windows. No, the window technology allows us, frankly, to capture free heat from the sun if we do the windows correctly. So there's really no compromises, and cutting your carbon footprint in terms of housing by, as you said, by about, well, I said at least 60%, but in your case, more like 80 to 90%. It's a very compelling message to say I can do all of that without compromising. In fact, improving my life, the comfort, livability, and so on of the house is actually goes up, which is very intriguing. And we always say, in the early days, we built back, and not me, but the folks who started on this in the 70s, built some incredibly efficient houses that were neither healthy, safe, nor durable. Why? Because we didn't understand the physics and science. That ended very quickly. That went for like 2 years. And then the science community, the building science community, as it grew, the folks that were my mentors said, no, we can't let that happen. Everything we do for energy efficiency also has to simultaneously make houses healthier, safer, more comfortable, more durable. Can't compromise. And in fact, it's true. So for example, you put in better windows that are far more efficient, but it also means those windows, the front face of that window, the inside face is much warmer, which means I can have higher levels of relative humidity, which we know really good from a health perspective.
The
In the wintertime.
Which was a problem in the past because we'd have condensation on our windows. We had to live in really dry houses. Remember that game you played with your brother to, get the static shock?
Oh, yes.
Yeah, yes.
Absolutely.
and
Rub a stuffy on your head.
Yeah, exactly.
the hair on the stuffy would be
Right.
standing straight out.
and so now you'd say, so simultaneously I made the house more efficient, but at the same time I allowed relative humidity to come up, so I'm healthier. That's interesting. And it turns out everything we do, add insulation to the wall. Well, that stops thermal transfer, that is heat energy, but also stops sound energy. So the houses are quieter, so you get a better night's sleep. Oh, these are all really interesting little pieces that I would say the Canadian building science experience, the journey that Watercolour is on, would say, boy, they did it right. Canada did it right, and really good research that said, we're not going to let it happen the wrong way. And so I always like to make the point, we know this is a unique community, and not too many, less than 1% of communities are built this way. But that should give people confidence because it's based on 50 years of research. We've been doing one-offs on this all over. As I drove up this morning, I could point out, oh yes. There was little people who were disciples, if you will, who built one or two and tried it. Communities on the way up. Brighton was a great example, a great builder there who did some wonderful houses. So all the way through, we can see this, but not in a community scale, not where we get to put together all the pieces at a scale, if you will, that makes it, some would say more affordable if just availability and affordability is interesting.
They can be part of that fortunate few that have access to something like this.
Right.
When you talk about durability, my mind goes to longevity, which is also more environmentally friendly or positive. You're more positive on the environment. What kind of comment would you make on the materials or the processes of building a home like this that have those durability and environmental impacts on just the longevity of the home?
Isn't that fascinating? In this community, you can see houses that lasted a couple hundred years, and you go, are new houses going to last like that? And the answer is yes. Again, because of the science of understanding what destroys buildings. And you can imagine the number one danger to buildings is moisture. Water destroys buildings, and water is unforgiving. So how do we manage water in buildings? And that same building science that we talked about does a really nice job. In the building science world, warm equals dry. So if I can take the structure of the house, the wood members, if I can keep them warm, and the strategy that Watercolour is using is to insulate more to the outside, which keeps the wood members isolated from the environment, now means that this building will last longer. And perhaps an example, in my own case, built a cottage, and my neighbor's a school teacher, in fact, a principal now, and I think he's retired now, but he bought an old house right beside us, built in 1868. Wonderful house. It's lasted since 1868. Did it ever leak? And yes, every rainstorm it leaked, but it lasted a long time. Why? Because it got wet, but then it would get dry. It got wet, and then it got dry. And in today's world, that's because it got dry, because it wasn't insulated. There was no insulation in the building. So you go, well, I don't want to live in a building with no insulation. That wouldn't be good.
No.
But if I'm going to take that old building, and here becomes the challenge, what are we going to do with the 17 million existing houses? If we're going to insulate them, then that changes the drying potential of the building. Oops, I can't allow those buildings to leak anymore. So before I do the insulation, I have to fix the water issues, flashings, details on the outside, or insulate on the outside, and think about that. And you go, well, that's going to change the look. Yes, but this is what they've done in Europe, insulate to the outside. So the existing 200-year-old structure stays dry, which means it stays warm and dry, which is really the critical part. So in this case, you look at the science of how you build a basement, for example, and the extent that's taken to ensure water runs away from that basement, the drainage layers, the drainage systems that are built into new houses, and specifically high performance houses, the way the walls are built, the flashing details to kick water away. That ensures the durability. And I'll add one other point. We talk about resiliency, perhaps further.
Yes.
Think about climate change and issues. People, what if the power goes out? It's an electrically heated house. What if the power goes out? Exactly. What if the power goes out with a gas heated home? The furnace still doesn't run. We're without power. What happens? The building starts to cool off, except if it's incredibly well insulated with no air leaks. That is, in an old house, 2-3 hours after a power outage, you're starting to get cold. In these houses, you can go literally days. How do we know this? Because it's happened, right? The ice storms up in this Ottawa district, those that did best were those who were living in high performance, and there's various names for them, R2000, Energy Star, Net Zero Ready, CHBA's program that Stephen is subscribing to. These are high performance houses that stay warm literally for days before you'd have to start worrying about them freezing. So that's another level of durability, resiliency, if you will, against climate change. So it gives people the confidence that I just don't need to worry as much about these houses. And
it's a peace of mind decision.
Peace of mind.
Yeah.
And I should go back. The forward thinking of those researchers back in the 70s, the first of those houses were under constant monitoring for years, in fact decades after. There's a research center in Ottawa where they have 2 identical houses that they have instrumented, that they're Canadian Centre for Housing Technology. Just amazing work going on that's monitoring those houses, that type of construction over decades to ensure that in fact this is reliable, durable construction.
Amazing. I know that leaky air situation. I think there's beyond the insulation. I've heard you talk about a aero barrier product that we use here at Landark. I'd love to hear a little bit just about how that works. I mean, how do we actually get into all those little nooks and crannies to make sure the building envelope is as tight as it is? And so we get that Yeti cooler effect. I know we have a video of Stephen talking about that, but from your perspective?
Well, thanks for asking, because this is an area I'm really enthusiastic about. So I mentioned there, as a young engineer, I moved back to Ontario, and I'm trying to promote this concept of these whole house ventilation systems. Builders not sure whether they need them or not. So I was doing these tests. We call it a blower door test. Big fan in the front door, exhaust air out. This was a device that was effectively invented by a fellow by the name of Harold Orr. He would give credit to others at the University of Saskatchewan to figure out where exactly are those air leaks. Because you look at a house and go, what am I looking at? Where am I seeing?
How would you see that? Yes,
so
it has to be measurable.
Imagine a big fan in the front door trying to suck air out, and you can feel all these holes. So since 1987, I've been air tightness testing houses. And every time I pull up, we call it the big red door, the builders are nervous. You know, they've got the caulking guns and foam guns, they're walking around, did we pass, did we pass, did we pass? Well, along comes this technology called aero barrier. I happened to hear of it, friends, colleagues of mine in the US were doing some research through the Department of Energy. I said, what are you guys up to? You got to come see this. So I flew to Minnesota and saw this device, this concept. And think of it as LePage's glue, like white glue,
yes,
but in a mist, right? In a mist. And you fog the house with it, this sticky stuff. And now instead of exhausting air out, you push air in. And as that mist is picked up by air currents and wants to leave the house, it impacts, not on the walls themselves, but on the holes, at the edges of holes. And so it's like a robotic caulking gun, if you will. In fact, I consider it the first application of artificial intelligence in the building industry. Instead
the little molecules know exactly where to
go. What we call blower door directed air sealing. Rather than a builder going, I'll put a bead of caulking there, because we see it all the time. I'll put some, and they're not really sure whether these are holes.
Right.
Well, and people say, well, that's a cheating. No, they're not cheating. Builders still build a great house. The big holes are easy. You can see those. It's the little holes. The little holes where the ants come in. Why are ants coming in? My mom was constant battle against the ants, right, in mom's house. My brother's house, constant battle against mice. Anybody who lives in an older home, they know, 2 months from now as it turns to fall, the mice are looking for a warm spot, and then they come. And they can get into incredibly small holes.
Yes.
So this technology finds the holes. And so we've gone from a world of, I hope I can get to this level of air tightness because we have a metric, and good builders did it, but they were always nervous. Now it means every builder, every house in North America, every house in the world could be built to this incredible level of air tightness. It's an easy button, if you will, for all builders. You use the term obsolete. Air leakage is now obsolete, or at least it should be. There's no reason not to do it. Somebody's going to say, could I do it in my own house? Well, a little bit of a challenge. There's this sticky stuff in the air, eventually dries out, falls to the floor. In new construction, not a problem. Just sweep it up as during construction. In existing houses, I got to cover all the surfaces. Not so easy to do.
Right.
Maybe at time of major renovation. So it points an advantage to new houses, but it's a great example of research from Department of Energy in the United States, starting way back in 1994. This product started. 7 years of research in the United States. I was pleased to help introduce it to Canada. I phoned that company and said, you should come to Canada. If you're coming, I want to help you. And it was so interesting for me as a guy who spent those years watching the angst on Stephen's face. Did I meet my requirements? To now go, everybody can do it.
Everybody can get there.
Yeah.
Is it a safe material?
Well, that's the point,
do
right?
you end up breathing this in your house because it's there?
Not.
Okay.
Yeah, the nice part is it's Green Guard certified. You can go all through the the math, but the key is it's rather heavy particles that fall to the floor. You've only used a very small amount, the amount that actually ends up left in the house, because imagine it's just covering small holes.
Right.
It's covering holes about the size of a very small window screen. The sum total of all the material left under the baseboards and so on is maybe what you would see on a screen, a dirty screen of a window. So there's really no risk. Unlike, there are some products that are still incredibly safe. For example, spray foam, where there'll be literally hundreds of board feet of it. It's still a great product and still very safe. But don't get me wrong, I'm a big fan of spray foam. Nothing wrong with that as an insulation. But this small volume material, people think, you painted all the walls in your house, right? Are you worried about that? Of course you should be. Low off gas, and we're all
Yes,
using
exactly.
this
Low VOC
material.
materials.
Again, a very small amount of it left. All it did was find the holes. The rest of it fell to the floor. You swept it up, and off you go.
Amazing.
It is amazing, frankly.
It's amazing.
It's I hopefully I don't sound too geeky over, enthusiastic over. It's just these kinds of things that come across. I've seen them over the years, and I'm so pleased to go, this is one that's got to get there.
And let's just stay on this topic for a minute. Maybe you could tell the story about your brother's stone older house and the number of air changes that it would have, to put it in perspective, because Gary Sharp, who is using the product, who is also a guest we need to have on the podcast.
Absolutely.
He loves it, and that's why we put it before we insulate and before we drywall, is we want to get that vapor barrier and moisture barrier as far out to the outside of the wall as we can.
Air barrier.
Air barrier,
yes.
sorry, air barrier. But this would be just interesting, I think, for people to hear the story, because Gary says the average air changes in a home are not what the CHB manuals that he helps edit says.
Right.
It's often many times that. But to give the perspective of your brother's experience with an older home,
sure,
would be nice.
So let's go back. Harold or others are doing this research in Saskatoon, and they realized they built this incredibly efficient house, and then they realize that biggest energy loss is due to this unwanted air leaks. It's really interesting.
Right.
And so how much is too much? And you start to imagine, how do I measure that? So we created this metric. The metric is what's called air changes per hour at a exaggerated pressure. Certainly not a pressure that a house would see every day. But imagine a 30 kilometer an hour wind on all sides of the house at one time. Clearly not happening. How many times an hour is the air being changed at that excessive rate? So to Stephen's point, the code imagines that if you do everything right, it would be roughly 3 air changes per hour at this exaggerated condition, would be the mark of a reasonably well-built, code-built house. Now, there's no requirement to actually test buildings. I think it's a shame. 27 US states now require testing of all houses.
Okay.
Vancouver, BC now requires testing of all houses, and someday soon Ontario will require it as well. I would say to anybody considering a new house, ask their builder, are you air tightness testing your houses? So keep that metric in mind, 3 air changes per hour.
Now we would have to measure that to be net zero certified.
And net zero says you have to be
net zero ready.
Net zero ready has to be 1/2 of that, 1.5 air changes per hour. Your houses get significantly lower than that, but the metric is in net zero houses 1.5. So my brother's house, built in 1910, beautiful home. I have to pay him $50. I have to buy him dinner every time I tell this story. So it costs me $50. But
sorry,
Jim doesn't mind. Jim's okay. He's heard this before. And so Jim's house, 26 air changes per hour at this magical condition. This is extraordinary, right? It's terrible. He's spending huge amounts of dollars. Interesting enough, he doesn't necessarily know how much he's spending because energy bills aren't a big part of our budgets, right? We often hear, how much are you going to save? Jim wanted to know, how much are we going to save? And I said, lots. So we did this test, 26 air changes. He goes, I don't know what that means. Like, what does that mean, 26 air changes? I said, Jim, if I took all the holes in your house and put them into one spot, be roughly the size of your front door. And immediately said, I think that's where the mice are coming in. So we did a whole bunch of air sealing work. Can't do aero barrier, but a whole bunch of air sealing work, air, attic and basement. And magically, that was about 9-10 years ago, every fall he'll report to me, no mice. Because there's
well, that's the thing that matters.
That's the thing that matters.
Right?
He doesn't necessarily know it, but he saved about $1,200 to $1,500 a year. An extraordinarily leaky house. He's still at 12 to 14 air changes. I mean, it's nowhere near your houses, and it's almost impossible to get a whole house at that tight. That said, so if I said, what's that 3 air changes look like in terms of size of hole, you're wondering, that's a small window, maybe, a 11 by 17 piece of paper. Your houses would be, a piece of paper about half of a 8.5 by 11. So 8.5 by 5 inch hole is left in the house. You might go, let's go find those. Sure enough, and Aero Barrier finds those holes, and most of your houses are well under 1 air change. And obviously, the tighter the better, within practicalities of cost and time.
Sure.
There's no advantage to a house being leaky. Why? Because you have, in these houses, 2 ventilation systems, more and bigger windows than ever before, and then this mechanical ventilation system. And I would encourage people to think about that. What's giving me fresh air? Because people ask me, so what about the air quality in Jim's house? 26 air change. The air quality must be great. Wait a minute. Not so. Because his house is a 2.5-story house with that old basement. Everybody knows warm air does what? Warm air rises. So all winter long, warm air is rising up in his house, which means air's leaking in at the bottom through the basement, through 100 years of mice and rodent activity, 100 years of asbestos and this, that, and the other, and it ends up in the living space. So old houses don't have good air quality, partly because they leak air in exactly the wrong spots. It's coming in places where you don't want. So right back to the start of our conversation, it's about high performance houses understanding that everything you do for energy efficiency should also make houses healthier, safer, more comfortable, more durable. And air tightness is a classic example of that. We did the research in the 70s, realized that air tightness is terrible from a energy perspective, but it also wasn't helping indoor air quality. And work that CMHC subsequently did on air quality in houses said the best houses are houses that are built with a really well-controlled air barrier. Control the air that's coming in and out, and then add back just the right amount of fresh filtered air for people living in the house. It's kind of an interesting journey, right? To understand how you started with energy, working towards comfort, health, safety, and then going, and it also solves some of our climate change issues. It's a really nice story.
Well, speaking of the nice story, we have a lot of people coming in who they are wondering about renovating an existing home with a new roof, a new furnace, new windows. And so as we were sharing before, can you share a little bit, Gord, in your words, not mine, about the merits of that, different quality of life that's possible to help people live their best life sooner rather than later?
And that's always the decision, right? Good money after bad. My dad used to say,
for sure.
When do I cut bait, and when do I say time to move on? And you think about, it is amazingly difficult in existing housing to get it right. And there's great programs. There's been incentive programs, Eco Energy, Canada Green Your Homes, have your house tested, make those changes, see what you can get done. In existing houses, there's only about 5 things you can do. You could top up the attic. Pretty much everybody's been there, done that. I could change my windows, but that's incredibly expensive. It's a huge investment. Can't justify it energy efficiency alone. Could I tear off the walls and re-insulate those? I doubt it. Maybe if I'm recladding an old sided building, but I'm not tearing off brick in an old building. Could I get the basement done? Sure, but again, the basement's a tough environment. In a basement that was never designed as living space, right? It was designed for pickles, is what it was designed for, right? That's about all that was there. We were
scary down there.
It's scary down there. Grandma's basement. I don't want to go there.
It's dark and damp and dusty.
Right. So you could spend money down there, and you could change out your heating systems. There's only 4 or 5 things, and you just can't get very far. So in the meantime, you're thinking about, and each one of those is interactive. That is, I can't insulate it until I first made it airtight, and I can't make it airtight until I've ventilated it, and I can't put in a heat pump. And the heat pump that you would need to electrify an existing house, they don't exist. 7, 8 ton heat pumps just don't exist in residential. So I can put in a heat pump, but it's only going to do a very small portion of the heating. So I want to encourage people, if you're listening, by all means, put a heat pump in your existing house. Just understand it's limited in its value because you're only doing about half the heating loads. Whereas here, all of the heating loads are being done with the electrification, the heat pump.
Because the home is so efficient.
Because the home is so efficient.
It's got to be both.
It's got to be both.
Have the mechanicals and the home being efficient.
Watercolour house uses 1/2 the amount of energy as a new house and 1/8 the amount of energy as an old house. That means the heating system that's needed in this house is 1/8 the size of a heating system that was needed in the 1970s house. So you can get cost-effective, small enough heat pump technologies in new houses. Really tough to get them big enough in existing houses. So you're always left with, well, I need a backup system. Can't get to full greenhouse gas reductions. So challenging to do. And I would just, that's the math that your folks, your visitors need to understand. Do I do that in the existing houses? Do I leave that to somebody else at my stage and age of life and family? Would I not be better just to invest in this, knowing that I've done my bit. I like to say if you put solar panels on, you've prepaid your electrical bills for the next 30 years, right? You've paid them, and now you don't need to worry about this ever again. Doesn't matter what happens to the price of fuel. Doesn't matter what happens. You now have that total flexibility that you're done. And I think there is a value to that. And in fact, I'll again go back to my brother Jim. We had this amazing opportunity. There's 5 brothers, but 3 of us got together and built a family cottage.
Oh.
And it's no surprise, it's a net zero cottage. And between there's 8 siblings and 8 kids. And it's been fascinating. My nieces, nephew, my sons and daughter-in-laws, they're all, wow, this is really cool. This we know is coming to us, but it's done.
It's future ready.
It's future ready. We've got solar panels, we've got the power wall. Power outage is not a problem. So much so that my niece said, "So Uncle Gord, you don't care how long we shower for now, right?" In fact,
need all the water you want.
it's actually changed the conversation, right? When you're making your own energy. Yeah. In fact, the neighbor comes over. "I hear you're making your own energy. Do you mind if I plug in my electric lawnmower?" Go for it. That's totally fine. So it changed the conversation when you get to that level and you go, "Oh, this is pretty interesting." So invest in the enclosure of the house such that you don't have to put in as big a mechanical system. And you can now imagine that I can generate my own off of this.
And even first-time home buyers, I know we talk about all the cosmetic things of a home.
Right.
We want quartz countertops. We want to have, shiny new fixtures. We want to have the best of every kind of flooring and all of that. But the mechanical system ends up paying back to the homeowner faster than any other investment that you make.
Exactly. And we don't ask the countertop to pay for itself. We don't ask the ROI. And that's the nice part. We know, and I was saying earlier that, in the same time that we've done this amazing job of high performance, houses have gotten more livable, bigger, brighter, wonderful new basement designs, 9-foot basements. Who knew that we could live in holes in the ground comfortably? Wow, that's basically double the volume of the house, double the square footage by making truly livable basements. Basements up until the year 2000 were never designed as living space. We weren't supposed to live down there. No. Now people do want this space, and it's big, bright, beautiful space if we do it right. There's a tremendous payback, right? What do you get when you can have a truly livable basement? Mm-hmm. What could you do with that? That's the real ROI. People often ask, what are the energy savings? And I would say this, how much are you wasting now, right? That's really what this is about. In your existing house, you're wasting money every month. If you do this investment correctly, and here's the magic of the net zero, CHB, Canadian Home Builder Association, so proud. It's not a government program, industry-driven, private organization, industry-driven program that says, what if we could design a building that only used as much energy as it was able to produce itself on site? And more importantly, what if we could do that so the average monthly cost of ownership was the same? That's the magic. You get all of this, and if you look at it, you go, so my energy bills go down, my capital cost went up a little bit, my mortgage goes up, but those two balance out. So you get a healthier, safer, more comfortable, more durable home for basically less than what you're paying now. I would say, don't worry about the math. We've done the math. It's affordable in that vein. It's all been designed to be such that whatever you're paying now, you're going to be paying less if you're in an old house, and whatever you pay in a new house, non-net zero, you're going to end up more affordable than these houses. It's a really nice win-win-win.
Amazing. Well, thank you so much for joining us today. I know we could talk about a lot of other systems in this house and keep people on the edge of their seat with all of your knowledge. So it just means we need to have you back for part 2 of Gord Cooke with Watercolor Stories. So thank you so much.
Thank you for the opportunity. As you can tell, after all these years, I'm still enthusiastic, mainly because of builders like Stephen and his group. I met your son last time. Just amazing to see how this is going to continue on. And there's still lots to do, but nice to know we're at a point where this can be done at scale without compromises to homeowners. Employing, I'll say again, that 50 years of Canadian building science research in a way that's practical, applicable, and affordable. It's fascinating. So thank you, Stephen, for your commitment.
We owe much of it to people like you who've been leading the way with a long obedience in the same direction. Because in until my friend Mark Wickham told me about it. I didn't even know anything about it. And that's what's so embarrassing as a home builder my whole life until 6 years ago.
Well, you didn't have the option of natural gas here as well, and our listeners can watch a video about that journey that the Natural Resources Canada produced for us, and it's an inspiring story of how we got to here where we are today. So thank you for joining us on the Watercolour Westport Stories podcast episode today. We hope that you've been inspired, and our goal here is to just create connection, community, and an opportunity for us to learn together, grow together, and build a better place to call home.